So today we're talking about how to do presentation for the weekly group meetings. So first thing before you do anything, please watch the seminar on seminars, this on the video tutorials. And second, read a paper on how to write a paper, which explains the structure of a research paper, which is obviously the same as for a research presentation. So with that, we go to the first page, which is quite important because it would contain the title, the name group meeting, so the purpose, your name, year, month, and day. So for example, today is 2022, May 09, okay? In terms of title, I just chose a JAX paper, which was just recently published by the Krischer Group. And so this is a rather long title, but all titles in chemistry should have one thing in common. So we have a reaction, let's say here, the cyclopropene reacts to this ethyl cyclopropane. So you can say formation of cyclopropane via carbomethylation of cyclopropenes, or you can say carbomethylation of cyclopropenes to give cyclopropanes. So that's basically always the same thing. Huh? If you look at this title, stereo and site-selective conversion of primary alcohols, so the conversion, stereo, enantio, diastero, selective, whatever, of some kind of starting material to allylic alcohols, and then via ruthenium. So then you talk about what you have here on, like what kind of catalyst, and sometimes mediated by butene, for example. Like if you want to emphasize, in this case here, a second reagent. So we have, for this reaction, let's go here, we have you have a primary allylic primary alcohol, this butane, and we have then the product. Okay, so here then you might emphasize by mediated, but typically we are only talking about starting material to product, and then you can turn it as you want. So like either you say starting material first and product last, or product first and starting material last, and you talk about the conversion. Don't talk about anything else in the title, so only talk about your reaction. Then there is an introduction part. So that's, I'm referring to this paper where I sort of pasted the corresponding pictures. The introduction part should show you why this reaction is important or why these compounds are important. So why are you doing what you do? What's the purpose of it? And obviously, what are alternatives for this reaction, and why your reaction is in some ways desirable. So this is the objectives part. So in the introduction, you should have the compounds somewhere, the compound class and its importance, and the reaction itself, or alternative reactions to this compound class, if this is what you're emphasizing on. And obviously the objectives, in what sense is your work different than what has been done previously? So why should we do it? And which answers do we want to answer? What are your research questions? In the objectives, obviously you can also introduce a hypothesized mechanism. Like if you don't know it yet, but that's what you proposed, like this is the way the mechanism could work, and that's what we should get. Discuss the mechanism, especially for complicated mechanisms. In terms of result, we are doing methodology mostly, so we always have tables, and there's always a model reaction. So model reactions, you have to think very carefully about them, because you will do them probably more than 100 times. And if you isolate, like here, 100 times the same compound, it's probably a little bit slow. So try to do NMR evaluation or GC evaluation of these compounds. Try to work with commercially available compounds or those which are easily available on multi-millimole scale, mold scale if not because if you run a lot of reactions, you don't want to spend half of your time synthesizing your starting materials. This is not interesting. And then, obviously, if you show a table, show us entry, show us what you are varying, show please in the reaction all the important parameters. So here, for example, the time is missing. We will check this later. And you can give additional information at the either orally or written, which I would prefer, at the bottom. So for example, here how the yields were, that they were isolated yields and the enhancer selectivities were determined by HPLC analysis. So you don't necessarily have to give me a title for the table, but just show me one table after the other. And be sure of your structures. So if I want to have clear answers, not I think this is the structure, or maybe, always compare your literature, your spectra with the literature well-known compounds, or fully analyze them so that you're sure what you're talking about. So we are in science, so we want to know, and we have the tools to know. So please use them. As I said previously, GC and NMR with analysis of your reaction with internal standards is the best, but we have seen here also sometimes surprises that the yield varied 10, some 20%. So you might be careful also that this is not, this needs to be carefully analyzed, the GC and NMRs. Okay, let's go to the next one. As always, mention as many reaction details as possible. So here, as I said, the time is missing. So yeah, I don't see any time. So it could be minutes, it could be days, it could be hours. These are things which I don't want to ask. They should be on your table, okay? So all the parameters which are important, please put them on the table. Here is a table which you can use, which you can copy and paste. This might not be the perfect table. You might do something better. Typically, what I want you to do is, and here for this we go into ChemDraw. You take your structures. So first you apply the ACS document. Then you take a structure, copy it, or your reaction, or your table. So table you can easily do just with lines. Then entry. Here, compound or conversion, and so on. And later on you have on the left-hand side, which I won't go into detail, this is something you can figure out yourself. You can align these things, or if you have different, let's say these are numbers, you can align them, okay? But you can just use the table I'm giving you in the PowerPoint. This will make it easier. And so once you have the structure, copy it into PowerPoint. And then go on here on the side, tie, and add only 130%. And then you should typically get the right size. So here you can see this here is wrongly sized. It's an old presentation. Let's put that back. So it's correctly sized. And then we go on size 130. And this is something which is quite well visible on. It's not too big, not too small. Don't give me more than 9 entries. I think that's also in the seminar of seminars. It's 9 entries is the maximum. Otherwise you get lost. Then there's obviously the scope. So you optimize your reaction. Then you show the examples. So please don't show me the reduced, the resume of what you did. Give me for every compound here, give me a list of all the reactions you carried out. So parameters you changed. Because as you can see here, there's always A, the standard procedure, but then there's always a little B or a little E or something where the procedure was changed for one reason or another. It can also be graph, so a table. Sometimes the graph is also easy to read, easier. So here we are dealing about 1, 2, 3, 4, 5, 6, 7, 8 times 4. So it's 32 points, 32 data points. And I can very easily identify the best conditions are for equivalence of the lithium chloride. So here I don't have to figure out a huge table with 32 entries. But just a graph makes it so much easier. If things are really complicated, show me NMRs, but this here is not a complicated NMR. It's a standard NMR of two of your starting material, which was fully consumed in two products. The two products are not complicated, especially these small molecules. So don't give me spectra where no spectra is needed. So here you could have just written, this is the reaction, or this direction. When you want to use color, use blue for important and red for very important. So red for me is a functional group, something you want to introduce. For example, here hydrochlorination. So the chlorine is probably more interesting than the hydrogen. So that's why I highlighted chlorine in red, and blue shows you where the hydrochlorination took place. So please show me things in red and blue only if they are important. If nothing is important, then just leave it all black. Please also show me, like once you finish with the results, with all the reactions. Let's say this is a reaction which you are currently investigating and you don't have the result yet. So please only put the arrow, the conditions, and maybe a little bit a remark. Let me show that to you, what I mean with that. So let's say this is currently done. I'll make it, just write hydrogen chloride, HCl, to make things easy. Obviously here you will give the full reaction conditions, and then don't show me the product, but show me rather nothing, or you can say what you want to determine. For example, determine yield, or let's say mass missing, or I have to, for one reason or another, I have to test something. So show me your remarks. If there are remarks are needed, if no remarks are needed, just a reaction, and next time you give me the yields or what you observed. And here's space for plant reactions. So things which are not yet covered, things which you think are intelligent to do, intelligent to figure out the mechanism, ideas you have maybe about other projects, or specific problems of your project. You're stuck somewhere and your yields are always low and you don't really know why. So please indicate that here. And the last slide is your thank you for attention.